Alright, how'd that homework go? The first page, 184, were there any questions? I don't even remember back that far.
That was so long. Okay.
So last week. 17, 23, 25, 27. Alright, so they're not that bad. You're taking the derivative, setting equal to 0, blah, 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 blah. Were there questions on the first one that you want to go over?
So much blood.
And maybe you just need more time with the answers. If you come up with something later and you're like, you know, I don't really understand what you did for this one, let me know.
What?
How about last night, 192?
It's not really on there.
How'd you like to, I don't know if you've done the homework yet, but the page from last night with the sign or the inverse sign, definitely worth looking at. Sure. It was number 17 from last night.
What? I didn't do anything.
Okay, I purposely assigned that one because it had inverse sign in it, so the more you can like be reminded of inverse trig as we go, the better, so that you'll be less likely to totally forget it later. Because by the time we get to the actual AP test, we're so far past inverse trig that it's hard to remember. Oh, I had another idea. You know how we take this practice test in May? Like a week before the real test or at the end of April? And do you remember me saying that like if you get a 5 on it, I'll give you an A for the year?
Yeah.
I changed my mind and decided that whatever grade you get, if you want it that for the year, I'll give it to you. So if you get a B on that test, and maybe your average for the course has been like a C and you've been struggling to get that B, you'll get a B for the year. I just decided, like, why let that just be something that works for the few people up at that, you know, A range, because the A is so tough, especially for this test. So I'm just putting that out there, you know, it's just another incentive to take that seriously and to get ready for it and all that stuff.
Is that A before or after the curve?
It's all after the curve.
Okay.
So once it's graded, like AP style, you know, if you get a B on it, if you have a B on it and you don't have a B for the year, you'll get a B for the year. So you can fail all the way up until then, and then everybody can get A's and B's. But I'm probably guaranteeing that you're not going to get a 4 or a 5 if you fail. But you never know. Okay, does that sound good? Fair?
What? Wait, I'm so confused. What if you like do bad? What if you like?
It won't bring your grade down.
Oh.
It's like if you have a no. It counts as your 4th marking period grade, period. But if it's better than what your average would be otherwise, you can have that for the year. Yeah. It'll be your 4th marking period no matter what, but then, yeah, I'll let it count for the final, for the whole thing. Okay. All right, so anyway, the homework from last night, page 192, number 17, it said, show that the function satisfies the hypothesis of the mean value theorem on the given interval. Find each value C, blah, 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 blah. Okay, so if you read my explanation, when it says first make sure that it satisfies all the conditions of the mean value theorem, that means make sure that it's differentiable and continuous on the interval. Well, if you remember the inverse sign,
What?
so you know how sine, like what the heck? We cut off the regular sign domain, not its range necessarily, so that when I take the inverse sign, those are switched. Whoops. So if the domain is negative pi over 2 to pi over 2, that's the range of sine. And if the range here is negative 1 to 1, that's going to be the domain. I can't draw this to save my life. I really can't. He goes like this or something? Yeah. Okay, so I guess I can draw it. This is sine of x. This is the inverse sine of x. It's a reflection of the line y equals x because it's its inverse. And since this domain, or since this range is negative 1 to 1, this domain is negative 1 to 1. So the whole point is, yes, the conditions of the mean value theorem are fine, are satisfied, because of the interval that they give us. If they gave us a bigger interval, you couldn't do the problem because we only define inverse sine on this domain so that it's a function blah blah blah. If you remember that from a couple weeks ago and from last year. So the answer to A is yes, inverse sine is fine on that interval or anything smaller. It wouldn't be fine on anything bigger. And then the second part is use the mean value theorem. So do f of 1 minus f of negative 1 over 1 minus negative 1. And make that equal f prime at some value c. And you're going to try to figure out what that value of c is. So I got to go inverse sine of 1 minus the inverse sine of negative 1 over 2 equals the derivative at c. And do you remember how to find the inverse sine of 1? It's like saying, isn't it, where on the unit circle is the sine equal to 1? That's what it's asking you. So at what pi value around the circle is the sine equal to 1? Happens up here. So we got pi over 2 minus, and then what's this one? Where's the inverse sine of negative 1, meaning where's the sine equal to negative 1?
3 pi over 2.
Down there. And the thing is, did I do this online? Yeah, don't we have to, we can't make it 3 pi over 2 because it's not in the interval of sine, so we've got to go the other way.
I got the same answer either way.
I think it might have worked. So I did the other way and made it negative pi over 2.
Because you just end up squaring it.
Yeah.
Oh, yeah, okay. That's fine. We get pi over 2 plus pi over 2 is just pi. All over 2. Is that what I got? Yeah. Okay, so this is the average rate of change, or that's the slope from the one endpoint to the other endpoint. Now I'm going to go find the derivative. The derivative of inverse sine is 1 over, oh gosh, what is it, square root of x squared minus 1 or 1 minus x squared?
1 minus x squared.
1 minus x squared. Yeah, I told you, I don't know it.
Come on, teach.
And this has to equal pi over 2. So from there I did a whole lot of tricky algebra, whatever. I cross-multiplied, divided by pi, and squared both sides. So I got 4 over pi squared minus 1 equals negative x squared. Divided by a negative, so I've got x is going to be the positive or negative square root of 1 minus 4 over pi squared.
Isn't that ugly?
Yeah, it is.
I was like, this can't be the answer. It's disgusting.
But it is. So to make this maybe make a little bit more sense, or to like try to give you the big picture of it, what is that value? What
I
is
think it's
this?
like 0.73.
Do you know that for sure? Or should I do it?
0.771.
0.771.
Close enough.
Okay, to kind of back up for a second. So what I did was I found the slope, I set it equal to the derivative, solve for x. What I just found out was that if I go back to the inverse sine, the average slope from the first point to the last point on the interval, negative 1 to 1, this average slope is pi over 2. Okay, that's what I figured out with all of this, that the average slope is pi over 2. Well, then I figured out that this thing has that same slope in 2 places, at x equals positive or negative, blah, blah, blah. So positive or negative 0.771. Kind of makes sense when I'm looking at this. At 0.771, I'm like here. I've got a tangent line that has the same slope as that secant line, as that average rate of change line, and negative 0.771, which is here. Oops, and again, has like the same slope. So I want you to get the big picture of this. That this is saying the slope from the first point to the last point, which I find with the slope formula, is the same thing as the slope at these 2 points. And I found those 2 points by taking the derivative, setting it equal to that slope, and solving for x.
You see how you use that squiggly sign for x?
Yeah.
If we don't use that,
They don't really care.
they don't care.
Okay, the squiggly sign means approximately, so once I take a decimal and round it, I'm supposed to put approximately, because I've rounded so it's not equals, but I've never seen them take a point off for that.
Okay.
try to put it so that I'm like consistent with that. Do you get it? This is if you get the idea within the complexity of this problem, it's a really good thing. This problem is very complex and tricky. You have any questions? Want me to like clarify? Okay. All right. Cool. Okay. So today's notes. Are you sure?
What?
Okay. No, I couldn't tell if you were like we're looking like you had a question.
No, I did like everything in decimal, so I don't know if I'm right
Okay.
or not. So,
It can be annoying.
yeah.
Number 18 is 2.2.
Quick question. Has anybody been trying any of these yet?
Yeah, I did.
Yeah. I have all the ones done. You know, it would probably also help if I put the answers on the e-board, wouldn't it?
The one limits question where the answer is 45. How do you get that? I forget how to resolve that one indeterminate question. You know what I'm talking about?
No, I'm looking now.
It's I think it's.
Oh,
yeah.
haha.
I didn't know how to resolve that, so I looked it up.
All right, I'm gonna wait on it and just like I'll put a little note that we do go over eventually, but I'm gonna do it right now.
Okay.
I have after we do like this section, I have a whole another group of questions to add to the list of stuff that you can do, and we're gonna have a quiz coming up because I know the marking period is gonna end before we know it, and I want to make sure that I get one in there. So I don't know. Next week sometime, beginning of next week.
Not Monday.
$112?
Please, not Monday.
I do want $12 actually.
Next one is
For what?
Green?
Oh, yeah.
Drugs?
Okay. It's not a lot.
Or I'm not gonna keep this $12. This is Capella. Just kidding. I'm just kidding.
Oh, thanks.
Is it really for the book?
Yeah, it's.
Oh, it's for the book? Oh, I will take it. I thought you were giving me $12.
Smart.
I thought you were giving me $12.
I thought you realized.
No, I didn't. Zach. Got it.
Just go tell.
Party!
Oh, how did that one meeting go where they showed a video of this?
I don't know.
You never found out?
Alright.
Are they doing YouTube?
Everyone okay today? You guys seem really quiet.
No.
Friday.
It's Friendship Friday.
Friday.
It's Friday?
It's Friday.
Is it-
Friday.
Friendship Friday.
Wait.
Actually.
I thought today was Friday.
Friday hasn't.
It's
Friendship
Friendship Friday.
you just-
Today is Friendship Friday.
No, you. I'm so mad because you made me think that it was Friday.
It is Friday.
It's Tuesday. How could you think it was Friday?
Friendship Friday happens on Tuesdays and Fridays.
Yes, it does.
This sucks.
What is Friendship Friday?
I don't know.
It's just day when I don't kick others' faces.
Or the other way around. Because that's obviously it.
People look tired today. So
Tuesday.
sorry.
Too much friendship.
There was just a lot of friendship last period, and that really wore us out.
There was.
In world cultures, there was so much friendship.
World cultures is a waste of time.
It
It's a
is.
waste of time.
It is the biggest waste of time.
It's good for harboring friendship, though.
And being really happy.
Yes.
Probably the best part.
How do you pronounce this?
The World Sierra watches this. We're sorry.
I'm not sorry.
Okay.
Do you want to take fun out of the curriculum?
Today gets actually pretty serious with what we have to go over because it's like guaranteed to be an open-ended question on the AB test, which means it would be an open-ended question on your midterm, and it is often an open-ended question on the BC test as well. So we're going to start graphing, and we're going to use calculus to figure out what graphs look like. And the reason why we've been doing this whole maxes and mins thing is because it kind of leads into this. We've already talked about how when derivatives are zero, we have potential smooth maxes and mins. And when derivatives are undefined, we have potential maxes or mins from corners or cusps. But then we can also have a whole slew of other things. So, at a critical point, and remember critical points are when derivative is zero or undefined. Okay, critical points are when zero or derivative is 0 or on the triangle ratio. Okay, one thing that can happen is, let's see, at a critical point, let's call it C, whatever. 3 things can happen. F could have a max at C. Okay, so if you have a critical point, it could be a max. And if it's a max, maybe it looks like this. Oh, so pretty. Or maybe it looks like this. Oh, not so pretty. Or F could have a min. Whoa. Oh, smile. A seagull, pretty beach. Or F could have nothing. I just wanted to narrow down the choices for you.
So how do we decide?
What's the thing at the top? It's like,
F prime is 0 undefined. That. And this is a C. At a critical point C, 3 things can happen. I'm just setting up, okay? So I'm like setting up the big bang.
I haven't established anything yet.
Okay, so we already established. What's that?
That really means nothing.
No, not yet. So we've already established that F could have a max at C, and maybe it's smooth and pretty, maybe it's like, I'm saying this a million times because it's so important. F could have a min at C, it could be nice and rounded, or it could be a cusp. Or F could have no local extrema at all. It could have been a horizontal tangent line. So this would be where the derivative is 0. I could have a vertical tangent line. And that would be where the derivative is undefined. Or I could have an asymptote.
But you wouldn't have a C then?
Not really. Well, I mean, at that C value is where the asymptote happens, but I would still be calling it a critical value. I would have still gotten it from the first derivative being undefined, but the function itself would have been undefined also. But, you know, if you're in your groove and you're not thinking about it, you might get that C and even forget to look at the original to see where it came from. Okay, here's the important part. Well, I guess it's all important. So far, the only way you've been able to determine if something is a max or a min is by looking at all the critical points and the endpoints and just comparing y values. The biggest y value is a max, the smallest y value is a min. And that's all that you've had so far. But check out what's true about the derivatives and what's in common with these and what's in common with these. What happens to the derivative before I get to this point C? They are all what? Positive, right? And after I pass over C, what happens to all my derivatives? Negative. So I have a derivative that's positive here, and I have a derivative that's negative here. Well, what if it was a cusp instead, but still a max? What happens with all my derivatives? Terrible marker. What's true about all my derivatives leading up to C? Positive. All my derivatives are positive, so my f prime is positive. And on the other side of C, all my derivatives are negative. So there's a connection here. When you have a max, big Oprah aha moment. When you have a max, not only are you going to have a critical value, obviously we're going to have a critical value, but when it's a max in particular, the derivative is going to go from positive to negative around that max, every time. If that doesn't happen, it's not a max. So for something to be a maximum value, not only do you have to have a critical value, but f prime has to change from positive to negative. And that's the part that's new. Okay, I'm trying to organize this so that you have every possibility together in one spot. But this is the big deal. That I'm going to go find critical points. And the critical points, a bunch of crap can happen. Something's always happening of note, but now we can be specific about what is happening at that spot. So notice down here, when I have like a critical value, say at this point C, my derivative went from positive to 0 to more positive. So it wasn't a max or a min, because my derivative never changed sign. I had a critical value, I had my derivative be 0, but it never changed sign from positive to negative or vice versa. So I had no max or no min. Same thing here, my derivative is positive, and it's staying positive as I go through that critical value. This one, yeah, my derivative goes from positive to negative, but C is an asymptote, so it like totally doesn't count as like being a potential max or min because it's an asymptote. So what do you think's true about this one? If my critical point, whether it's from f being 0 or f prime being 0, f prime being undefined, what happens with my derivative here?
All negative.
Negative and then all positive. So f prime is going to go from negative to f prime being positive on that side. Same thing over here. If my critical point was an undefined 0 or an undefined place, my derivative is still going to go from negative to positive. And that's how I'm going to know I have a max or a min, in this case a min. So f has a min at C if f prime changes from negative to positive. Okay. I'm not going to get through as much as I want to, but that's okay. So here's what a problem's going to say. Okay, say f of x equals x squared plus whatever that is, minus 3 times e to the x. Let me if you get freezing. We're going to start the problem just like we did before. We're going to find the critical values first. So we're going to find all critical values. So we're going to take the derivative. So to take the derivative of this, what do you need?
Product rule.
Product rule. So we've got the first times the derivative of the second plus the second times the derivative of the first. I'm going to take an e to the x out and be left with x to the third, squared, sorry, plus 2x minus 3. And I'm setting this equal to 0. Is there any place where this derivative is going to be undefined? Do I have anything in the denominator? No. If I have no denominator, my derivative is really not going to be undefined. Yeah. I'm in a negative exponent, but that's really a denominator too. So without a denominator, there's really not a place where the derivative is going to be undefined. I can't think of anything unless you're talking about logs or something, but we'll get to that later. So I set it equal to 0, and I'm going to solve for x. So I've got e to the x equals 0. And I've got x squared plus 2x minus 3 equals 0. Is e to the x ever going to be 0?
Nope.
Nope. Okay, no matter what power I plug in, if it's e, which is 2 point whatever, to a power, even if power is negative, it'll turn it into a fraction, but it'll never be 0. So I have no solutions from that particular spot. Over here, it's factorable, x minus plus 3, x minus 1. So x is negative, negative 3 and 1. Okay, these are my critical values. These are my potential places for maxes and mins. Now, I don't have any closed interval, so I'm not going to test endpoints on them. I'm just going to look at them. And here's the general practice. We're going to make a number line. And and I'm going to put my critical values on the number line, and I'm going to label it with F prime up top and F on the bottom. When you get into the AP test and you take the open-ended section, it's important to show your work, and they're often going to say justify or explain. A number line is a perfect explanation, and that's all that you need to do. So when I'm answering a question about this, if I have a number line that's properly labeled, I don't have to write a whole sentence or whatever. So this is a good habit to get into. And all I'm going to do is pick numbers from each interval, and I'm going to plug them into the derivative. And all I care about is, do I get a positive number or do I get a negative? Because what I'm looking to see is, at each critical value, does my derivative change from positive to negative? In which case I have a max. Does my derivative change from negative to positive? In which case I have a min. Or does my derivative not change at all, and therefore I don't have anything? So let's go with the positive side first. Let's plug in like 2. My derivative is here. You want to be able to do this somewhat quickly. So my advice is, we don't care exactly what number you get when you plug in 2. I just want to know if it's positive or negative. So if I plug in 2, e to the second, positive or negative? Positive, and that's always positive. So now I just have to worry about this. If I plug in 2, I'm going to have 4 plus 4 minus 3, positive or negative?
Positive.
Positive. So I have a positive number over there. I don't care what it is, I just want to know if it's positive or negative. Pick something in between negative 3 and 1. I pick 0 if I can. So plug in 0, positive here, 0, what does this give me? Negative. Plug in like negative 4. Again, e to the negative 4th is still positive because it just gives me a fraction. Negative 4, so I'm going to 16 minus 8 minus 3. Positive or negative? Positive. It's not always going to flip-flop like this. That's why you have to test it. You can't like predict what it's going to do. So, what this means is, wherever f prime is positive, I actually didn't quite talk about this, but anyway, wherever f prime is positive, this is going to be increasing. And I didn't really talk about that yet. I'll get to it. We'll just go through this because I have the number line up. Wherever f prime is negative, my function is going to be decreasing. And where f prime is positive, again, my function is going to be increasing. That doesn't matter so much. We'll get to that in a little bit. What does matter is, when my function changes from positive to negative, what's happening here? I got a max. Okay, when my derivative changes from positive to negative, I have a max. And when my derivative changes from negative to positive, I have a min. They're going to want to know where the max and min is, so I'm going to have to list the points. If the x value is negative 3, do I plug that into the derivative or the original to get its y value? Original. So plug it into the original and you're going to get 6 over e to the 3rd. That's gross. And plug in 1, you're going to get negative 2e. It's a lot of work just for that. We're going to stop, but do you have any questions? All right, there's no homework. We're going to stop and we'll just continue tomorrow.